All right. Well, why don't we go ahead and get started? My name is Karen Solverson, and I'm the Communications Director here at Mississippi Valley Conservancy. And I'm glad that all of you are joining us this evening. And we're also recording it so we could share it with others later. But there are a few faces and names that I have not recognized. So, for those of you who are not a member, let me just tell you a little bit about the Conservancy. We are a land trust organization here in La Crosse, and we work with 9 counties. And our goal is to preserve and protect native habitat in those 9 counties. Currently, we've got 26,700 acres that we're protecting, both with our land management teams and with restoration crews that go out. And our biggest exciting part is that 7,000 of those acres are actually open to the public. So, and there's no cost for that. And a lot of people enjoy hiking, bird watching, snowshoeing, and really just enjoying nature if they don't have their own backyard or if they want to go out looking for fall leaves or the spring birds and migration. So we have quite a bit to offer to the community. And one of our conservation goals is to protect large tracts of forest for the birds that come migrating through here. And we've really done a great job. We work with the Kickapoo Bird Initiative and the DNR and lots of other local groups and find ways that we can work together to protect these large tracts of forest. And Dr. Anna Pidgeon will be telling you a little bit more about why that's so important and share her research on this topic tonight. So, Anna, I will let you introduce yourself, but welcome Dr. Anna Pidgeon of UW-Madison.
Thank you so much, Karen. I really appreciate the opportunity to be talking about this topic, birds of southern Wisconsin, gains, losses, and opportunities in the face of development. And guess a little bit about myself. I'm from Minnesota originally, but I've done uh, research in Washington State, New Mexico, and a lot in uh, Wisconsin. I've been here for almost 25 years at the University of Wisconsin-Madison. Um, so without further ado, there we go, start on the topic today. So I'm going to first talk about kind of the big picture of birds in the US, then talk about some challenges to them associated with development, particularly in forested areas, both kind of long-term broad scale challenges as well as more short-term or immediate situations that are challenges, and then some opportunities for bolstering resilience of forested ecosystems. So big picture here, these two charts show groups of birds organized on the left by taxonomic relatedness, these, and on the right by really broad habitat categories. Not that the top one is a habitat category, but see how they're organized. And at the bottom of each chart is an axis with numbers, and bars that point to the right of 0 indicate increases in populations of those birds, whereas bars that point to the left indicate declines in population. And this is since 1970, so the recent 50-year period approximately. And you can see that sadly, bird populations, most groups have declined, some quite strikingly by up to or over 75% in the case of Old World sparrows, which are introduced species, so we're not so much worried about them. But anyway, the percent decline is in terms of population size. Population loss is not restricted only to rare and to threatened species. You see lots of groups here, and it includes widespread habitat groups and taxonomic groups, including some fairly common species. A big exception to this negative trend. I guess before I leave this slide, I'll point out oops, I think I just marked up the, okay, let's maybe, how do I get back to, here we go. These groups here at the bottom all have right-facing bars, so turkeys and grouse, raptors, ducks and geese I want to especially focus on. You can see also waterfowl have had this 56% increase in population size since 1970. And so those are big exceptions to the general negative trend. So just for example, highlighting wood ducks, Joseph Grinnell, a famous naturalist, wrote in the journal Field and Stream in 1900 that that wood ducks were very scarce and they were likely to become extirpated before long. So they've gone from that at the turn of the last century to being one of the most common waterfowl species breeding in North America. And we owe this to, well, in the early days, regulated hunting. So there was not regulated hunting at the turn of the century when Grinnell wrote that quote. So that occurred for a couple of decades, but then habitat management, protection of wetlands has really bolstered this and other waterfowl species population sizes so that they have increased over the last 50 years, excuse me. Another group that was highlighted in that slide as increasing was turkey and grouse. Now, don't have a good story for ruffed grouse, but wild turkey have made a huge comeback from being extirpated, eliminated from the state in the 1900s to today being found in every county in Wisconsin and having very robust, thriving populations. This is a big success. Other examples of success are raptors, and especially these two, peregrine falcon, bald eagle, which both had been on the Endangered Species Act when it was enacted in 1972, but were removed later. Both of these species were virtually eradicated from Eastern North America by pesticides, specifically DDT poisoning by the middle of the 20th century. And two things really helped their fate, as well as that of other raptors. That was banning of DDT, and then the enactment of the Endangered Species Act. So these were two species were both placed on it fairly early, and that allowed concerted efforts at transplanting birds from healthier populations in Alaska, and other significant recovery efforts that have contributed to their huge success in population size. And in fact, here you can see a map of bald eagle nests in the 1970s versus more recently, and can see that they are thriving in every part of the state. It's not only eagles and peregrines, as I alluded to, but many raptors, which both suffered from DDT poisoning, which interfered with their reproduction, as well as suffering from heavy persecution, have had very altered paths with protection afforded by the Migratory Bird Treaty Act and the elimination of DDT. More and more raptors are thriving and apparently becoming comfortable with living in cities. And not all raptors can live in cities. Those that do tend to be generalists in their behaviors and tend to be those that normally occupy woodlands and forests, such as these 4 species illustrated here, or also the peregrine falcon, which is a cliff nesting species, but can use buildings as surrogate cliffs. And finally, I want to highlight another huge success story, the sandhill crane. As I was sitting here in my office around 5 o'clock, I looked outside and I'm in, urban Madison, and walking on the grass by the sidewalk was a pair of sandhill cranes. They once had nearly vanished from the Midwest. They've bounced back and returned by the hundreds, or by the thousands, I should say, and the population is booming. The biggest boost for sandhill cranes reemergence is the conservation and restoration of wetlands, marshes, and prairies, and the fact that they are not persecuted. So they've learned that cities and suburbs are potentially suitable habitat. Okay, so going back to that big picture slide, I've highlighted some of the kind of good news stories for certain groups of species, but there remains this group that I've outlined in red, which all have declining populations since the 1970s. And I want to focus on some of the things associated with development, specifically housing density, that contribute to problems for these species. So this is a map of housing density from 1960, and I'm going to show a series of decadal maps. They're based on US Census data. And you can see that the cursor again, it's lost. Whoops. That the red, bright red and dark red colors indicate the highest housing density. So you can use that to see the cities. So 1960, 70, 80, 90, 2000, 2010, and 2020, and then projected density for 2030. And you can see how housing density has grown and grown. And some of this increasing density is infill in cities, replacing, for example, single family homes with apartments, et cetera. And that is a good kind of growth. But conversion of habitat or building adjacent to wild areas is pretty bad news from a wildlife perspective. So I'm going to focus on housing density in forested ecoregions. And these are shown with the numbers here. Sorry, this isn't quite as attractive a map, but the darkest colors indicate the highest housing density again. And so we can link birds to housing density in forested ecoregions by making use of this great long-term survey done by citizen scientists, expert birders. Maybe some of you contribute to this. It's called the North American Breeding Bird Survey. And as you see on the bottom, map of the country, and each of the dots on the national map represents a 25-mile section of rural road that's referred to as a route. And along the route, a volunteer expert birder stops at each half-mile spot and records all the birds he or she detects for a 3-minute period, and then gets back in their car and goes to the next half-mile point and does the same thing, and does that for the entire 25-mile, 50-stop route. So you can see in the upper left an example of all the stops along one route. And some of these breeding bird survey routes have been surveyed each year, each June. They're always done at the peak of breeding season. So here at this latitude, that's in June. For over 50 years. This program started in 1966. And so here's an example of the kind of rural route along which the surveys would be done, with one person with binoculars, the detector or the person surveying, and the other person is the recorder. And so we can link data from these breeding bird survey routes. And here you see one on the left from northern Wisconsin. It's the wiggly line, and we put a dot at the center point of that route. And the other from just south of Madison on the right. You can see that housing density is much higher there. So to compare housing density to relate birds on these routes to housing density, we kind of clip a 20 kilometer diameter circle around the route and analyze the housing density within that circle compared to the birds on the route. So again, these forested ecoregions, and only looking at housing density within the 20-kilometer circle around each breeding bird survey route in each of these ecoregions. So I'm now showing you a chart that has the ecoregions arranged along the x-axis from lowest housing density on the left. You can see the Southern Rocky Mountain mixed forest ecoregion has the lowest housing density, so it's farthest to the left. And the Eastern Broadleaf Forest Oceanic ecoregion, I didn't make up these names myself, these are Forest Service standard names, has the highest housing density, and it's on the far right. And each ecoregion has 4 columns, one for 1970, 1980, 1990, and 2000. So you can see that in each case, housing density increases in each ecoregion as you move through those 4 decades. So then we're going to add on information about bird species. So first, we see patterns when we related birds from the breeding bird survey routes, censused in the same, surveyed in the same years as the US Census data was collected. And again, here the ecoregions are arranged from lowest housing density on the left to highest on the right. And if you look at the y-axis, you see that bars that point upward indicate a positive association between the number of forest and woodland bird species and housing density. So that's in the 2 leftmost ecoregions, those with the lowest housing density. But then we approach a threshold at which there's either not kind of a neutral association, no bar, or flipped, some up, some down. Then we move toward all negative associations as we get into ecoregions to the right that have greater and greater housing density. So this is all forest and woodland birds together. Then can look at subsets of that group and see that the positive relationship between houses and birds persists to a greater housing density, 1, 2, 3, 4 ecoregions before that relationship turns negative. So in the negative situation, there are fewer species of permanent residents, species like cardinals, nuthatches, chickadees, and woodpeckers, where there's greater housing density. Next, and the opposite of permanent residents is this group, neotropical migrants, those birds that travel really long distances from their breeding area here in the upper Midwest to southern Central America and northern South America. And this group is quite sensitive to housing. They have a positive association with housing just at the lowest, the ecoregion with the lowest housing density. And as you move to the right, all the relationships with housing density are negative. And I'm going to contrast that with this group of birds called synanthropes. So that's birds that have strong affiliation with or association with human areas, so lawns and gardens, etc. So birds like robins, house wrens, house finches, and goldfinches. So what is it about this area in the vicinity of houses that makes habitat so strongly changed, positive for some species, negative for other species? And we can see that, there's just some examples of houses in rural areas. In some cases, like in the upper right, there's a huge lawn. It has a radically different structure, high contrasting structure with the adjacent forest. In other cases, though, like the lower left, you see that the canopy is largely preserved around the house. In the lower right, you see this exotic species that's been planted, the blue spruce. A lot of birds that are nest predators, like common grackle, blue jays, tend to like to nest in conifer species. So thinking about how housing density increases over time, we start with a kind of a theoretical unbroken forest like this one. And as houses are built, that unbroken forest becomes perforated by patches around the houses that don't contain forests. See the clearings with, as time advances further, we see stronger edges developing as roadways are widened. This decreases the amount of interior forest and opens up the canopy. And when you come down from the aerial view to the street view, you get a greater sense of how the forest is changed in association with housing. You see the hard edges between the forest and the ground cover or the lawn, dramatic changes in vegetation structure. And at these edges, conditions are different than they are in the interior of the forests. In the interior, light is filtered, not harsh. It's cooler temperatures. The wind generally does not penetrate very far into the interior, and humidity is higher inside than outside of forests. And soft-bodied insects, some of which may also be weak flyers, like mosquitoes and midges, and some that are easily desiccated in low humidity, like caterpillars, and species that occupy the forest floor, are in higher abundance in forest interior conditions. And insects, all of these that I've mentioned, are really important sources of protein and lipids for small birds, for small forest birds, especially as they prepare for and go through reproduction, and also as they molt their feathers after they reproduce. Other things associated with housing are escapee plants. Many plants don't escape, aren't problems, but there are some that are notorious, as I'm sure you're all aware. The increased light at the forest edge favors honeysuckle on the upper right. Buckthorn does particularly well in moist soil sites. Garlic mustard modifies soil chemical properties and can destroy fungal associations of native plant seedlings, which are necessary for robust growth. And barberry, which is probably the most attractive of this lot, invades forest understories and eventually resulting in tangles that are difficult to get through. And all of these plant species interfere with reproduction or regeneration and growth of native plant species that require light. Yet other changes or things associated with housing include changes in resources. We create a lot of great foraging habitat on lawns for brown-headed cowbirds, in the lower left. Our bird feeders are also quite attractive to brown-headed cowbirds. So some species are favored by our feeding activities. Other species, especially those that eat flying insects and foliage insects, are neither favored nor disfavored, but we build populations of some species and are neutral with other populations of species through these activities. Some mammal species are also favored by the conditions that we create when we develop housing. The native mammal species seen here are, at the same time that birds are nesting, they also are looking for protein to nourish their own developing young in utero and to help with milk supply after the babies are born. So they are, even though you think of them as the squirrel and the Peromyscus there, the deer mouse, as being herbivores, they will happily eat eggs and the mouse will eat baby nestlings, baby birds. Um, cats Cats are here because people allow them to be. The advantage that cats have is that they are familiar to so many people, while the disadvantage that many of our forest birds have is that many people haven't learned to recognize them. And of course, the old adage, I think it's true, what we don't know, we can't love. So cats are dearly loved, and what they're doing is not apparent to many people. Um, some dogs are allowed to be off leash during nesting season, which has a very negative effect on ground nesting birds, from American woodcock to eastern towhee to black and white warbler. The opossum and the raccoon are certainly native mammal species, but they take advantage of the fragmentation that housing provides. They take advantage of gardens and compost piles and other things associated with housing. And I'm certainly not saying there's anything, bad inherently about any of these species. It's just that they are favored by housing density, which builds up their populations and increases predation pressure on bird species. The two bird species on the right side, the European starling and house sparrow, are of course competitors for cavities with native bird species. The hard edges that we create for example, again, in the upper right picture, are great places for avian predators to perch and observe and hunt from. Also, brown-headed cowbirds are at higher abundance at these edge sites. This is a chart from an old study, but things haven't changed in the last 20 years or so. And you can see that surveys of these three species, brown-headed cowbird, blue jay, and crow, in every case showed higher abundance at edges than at the interior of species. So cowbirds looking to lay their eggs in other species' nests are abundant here at the forest edge, far more so than they are in the interior of forests. So to summarize, housing development is kind of inadvertently accompanied by a lot of changes to habitat. Recalling that image of the contiguous forest landscape that we started with, you can get a sense of the great, major changes that occur to the forest over time as housing density increases. Losing forest interior conditions and gaining edge conditions is a common theme, and this has a lot of consequences for the physical conditions, the light and humidity, and for species that respond to these changes, the natural behavior of predators and the natural behavior of cowbirds is influenced by these changes in conditions. So summarizing slide here. So one thing I have not talked about yet is, you see on the the left side, fire suppression. Fire suppression is also something that has accompanied increases in housing density. Work by a scientist named Jed Mounier of the Wisconsin DNR suggests that fire has been, until the time of colonization, fire has been a reliable and regular part of the majority of Wisconsin's landscapes for thousands of years. Fire creates openings in forests and woodlands, and those openings are places where there are more understory flowering plants. But of course, to protect life and property, as housing density has become more frequently, we suppress fire. Under fire suppression, certain tree species are advantaged. Trees that are called shade tolerant, like maples and basswood, and trees that need sunlight when they're young to regenerate don't reproduce. And in particular, white oak and bur oak regeneration have suffered under fire suppression. Well, so what? There's still plenty of tree species in forests, but I am a proponent of oak regeneration. And the reason is that oaks, we've gradually realized over the last maybe 15 years, are important in supporting very high caterpillar density. I'm showing you here a table of data that was from a study that was done, actually two studies, one in the Mid-Atlantic region and states, and one in Pennsylvania. And both showed that in terms of number of caterpillar species, the genus Quercus, which is the oaks, support the highest number of any tree species found in those eastern forests, followed in the eastern forests by cherry species and willow, etc. So you see the number of caterpillar species, more than 500 species supported in those eastern forests on oak. That's important, again, for forest and woodland nesting birds as sources of food for their young, but also for themselves. So caterpillars and other soft-bodied insects are quite important. I, about 12 years ago, had a student named Eric Wood who was interested in birds using trees during spring migration. And he focused part of his work, part of his PhD work, in the Kickapoo Valley Reserve. He wanted to know which tree species are most important to migratory warblers during migration. And he had a sense that oak played a big picture, but he wanted to collect data to find that out for himself. So he and his assistants spent many, many hours with their necks, getting kinks in their necks, with their binoculars up in the sky and a digital recorder held at their mouth, and looking at warblers foraging on trees to determine the amount of time spent in seconds foraging on a given tree species, and the number of prey that they acquired during that foraging. And this was integrated into something called an attack index, and a number of successful swallows of an insect over the number of seconds that the bird had spent foraging. So these are birds that are passing through the Kickapoo Valley Reserve on their way to boreal forests where they nest. And in particular, the focus was on Tennessee warblers. And he thought, I read this study that I just showed you from the eastern forests about how oaks are so important. And so I assume there are more insects, soft-bodied insects available on oak. And I'm going to arrange a chart that shows caterpillar numbers or diversity according to that eastern study, the Talamy and Narango study, the x-axis, and then bird foraging success, that attack index, on the y-axis. And I'm going to see a really clear relationship, but he didn't see that at all. Then he got to thinking about the architecture of different tree species and the biology of birds, especially these warblers. Not all birds can hover to pluck insects off of leaves, but many, including many warbler species, have to perch and actually reach out to glean insects from leaves. And that is a much easier thing to do on a sturdy branch that of a tree species that has short leaf stems or petioles than it is on leaves with long, flimsy stems. So you can see the contrast here between the oak leaves, which have the short petioles and sturdy branches, and the maple leaves that have very long, flimsy petioles. And so he redid his chart, and this time he arranged the tree species according to their leaf petiole length and compared that with bird foraging success, that attack index. And he found a really strong relationship. So he found that birds had the greatest success, you see up there at the top, white ash, on ash and elms, and also oaks, and the least success on those flimsy petioled species like maples and basswood that you see on the far right. So that is another factor in the importance of oak for a variety of bird species. Okay, I'm going to turn now to highlighting the work of another student, Maya Pershey, who focused her efforts in the Baraboo Hills, and she was dissatisfied with having to use data from the eastern forests, and she wanted to understand whether trees of our Midwestern forests had the same rank, tree species had the same rank in terms of hosting invertebrates as had been shown in those eastern forests. So she measured a whole bunch of branch samples, and then instead of looking at just species, she looked at biomass of insects. And she found indeed that the two oak species, white oak and northern red oak, had the highest biomass of caterpillars in the Baraboo forest plots that she measured. So these letters above the lines indicate that, like, A for white oak indicates that there was clearly more biomass, statistically more biomass than B tree species, the hickory and the basswood, and that had clearly more biomass, statistically demonstrated, than all the trees that have a C above them. And the AB there for northern red oak means that it's not different than the A and not different than the B. Anyway, the point is that in the Midwestern, in the Baraboo Hills forest, she found, like the eastern forest, that oaks were absolutely important, or the highest insect biomass, but a slightly different ordering of other tree species. And she did this work during May and June in several years. And she also measured the importance of several shrub species in terms of biomass of insects, and found that witch hazel was the most important. Okay, but then focusing back on oak again, here I'm highlighting several, these 12 images are focused on the area in the national map in green, so the driftless area. showing the relative dominance of oak, of a couple of different species, but pointing out the oak in particular here, just before settlement, in the time we call pre-settlement, in the mid-1800s, you can see that white oak is especially dominant from its dark colors. And then the 1990s, where we see kind of other species, a hodgepodge of other species being dominant. And then is also in the 2000s, the colors have deepened. So we've continued to lose white oak as a dominant species through the driftless area over this time. So fire suppression is where I started with this. Knowing that fire restores oak to woodlands, my student Maya wanted to know what's the effect on other members of the forest community here, and in particular on caterpillars and on birds. So she set up 5 pairs of sites. 5 of them were managed by the Nature Conservancy, thinned and burned to create conditions in which white oak would regenerate. And 5 of the sites were paired or matched as closely as possible to those managed sites, but they were in areas like state parks where they were not being managed. They were left to let succession take its course. And in each of these charts, I'm going to show the areas that were thinned and burned, called managed, and they're shown in brown, and the sites that were not managed at all are shown in blue. And as you would expect, in the sites that were thinned and burned, there was lower canopy cover, there were more oak in the canopy, because that's what the Nature Conservancy was wanting to encourage regeneration of. The density of understory plants was lower, but there were, because more light was penetrating to the forest floor, there was greater herbaceous cover, more flowering plants. She also found that there were both more caterpillars and more aerial insects. So in these charts, the asterisk or star is kind of mean biomass for the caterpillars or aerial insects respectively. And yeah, you can see that it's a little messier, but there's definitely more of both in the managed with thinned and burned sites. And when Maya looked at the number of bird species, she found that the greater the proportion of oak at a site, the higher the bird richness, which means just number of species. And the greater the caterpillar biomass, the greater the number of bird species. For individual bird abundances, looking at here at 3 species that forage in the understory, and despite the lower density of the understory, all of these species, the house wren, the indigo bunting, and the American redstart, all had higher abundance or higher density, same thing, in the sites that were thinned and burned than in the unmanaged forest sites. Other set of species, these focusing on their foraging efforts in the midstory and the canopy: scarlet tanager, cerulean warbler, blue-gray gnatcatcher, all greater abundance in managed sites. We didn't have very many aerial insectivores, flycatchers, to measure, but the one that we did, the eastern wood pewee, showed the same trend with higher abundance in the managed sites, the brown sites. When we looked at species that forage on the ground, these 4 species, we see fairly mixed results because fire, of course, is eating up the duff, the leaves on the forest floor, and therefore there's less habitat for ground-dwelling invertebrates. And yet we see the two on the right, the American robin and the eastern towhee, still had higher abundance in managed sites, thinned and burned sites, whereas wood thrush and ovenbirds showed a slight decline in abundance in response to this management. So to summarize the effect of fire in woodland sites, and I neglected to describe this very fully at the beginning, but these managed sites are embedded within contiguous forests. So there's unmanaged forest, and then there's a site that the Nature Conservancy really focused on changing the structural character through removing some species like basswood, just cutting them and leaving them on the ground, and then burning several times. And we see the kind of summary of the effects here in this image of how the changes in arthropod biomass and vegetation structure were reflected in the bird community. So here we're looking at the same sites with black lines connecting pairs of sites. So managed on the left, unmanaged sites on the right, and on the left, we see richness or number of species per site. Clearly, at every site, it's higher in the sites that had been thinned and burned. And then overall density of birds or abundance of birds, again, clearly higher in the managed sites than in the unmanaged sites. So clearly, restoring fire to the landscape benefits a majority of species. And I acknowledge that a couple of species did not benefit. Ovenbird would be the one in particular that, and wood thrush as well, that we're concerned about. But having a patchwork of areas that are exposed to fire or experience fire and sites that don't, I think is important for increasing the things that many of our declining species need, the food and the structure. I want to turn now to thinking about migration period. Small birds migrate at night, probably for several reasons. There's greater relative humidity, so they have a less challenge of becoming dehydrated during their high exertion flights. The air is less turbulent at night, so it makes for less energy expenditure. And there are fewer predators to contend with at night. Birds, songbirds use a number of different navigation aids, but on a clear night, the stars alone provide sufficient information to navigate by. But artificial light at night is disorienting. And here we're seeing these beams, which are the tribute lights at the Twin Towers Memorial in New York. You can see all the birds that are, in quotes, trapped within these beams of light. So as you know, this is right next to the coast, to the eastern seaboard, and that's a huge migration corridor. So birds are funneling twice a year up and, down or south and north. And during that time, the compromise that's been worked out is that volunteers observe these tribute lights all through the migration period twice a year. And when a number of bird species or bird individuals get trapped in the lights, they are momentarily turned off. and that kind of, in quotes, frees the birds and they continue on their migratory path. If that isn't done, they exhaust themselves in these tribute lights and they end up on the platform and at risk of being stepped on or predated, etc. But it's not just really powerful artificial lights like this that pose problems for birds migrating at night. A number of studies have assessed the effects of anthropogenic light on nocturnally migrating birds, most in urban areas, but there's accumulating evidence about night lights in rural areas. And I want to discuss one study that was conducted just north of Lake Erie, east of Detroit. And it focused on ground level lights such as this one from a house and building lights like this one and single street lamps. And the researchers paired, first of all, the study was done in rural areas and they paired sites with a street light or a building light or a yard light and sites nearby that did not have artificial light component. And they put out recording devices to capture the nocturnally migrating birds, their nocturnal flight calls, and the results were quite striking. Even these individual lights affected birds, it appeared. So the sites with lights are shown on the right of each of these charts by the open circles, and the dark sites that had no light are shown on the left with the black circles. And so the pairs are connected by a line, and you can see that the number of flight calls, so an indicator of the abundance of birds, was higher at the sites with light, suggesting that they are attracted to the light or disoriented by the light. At any case, they're affected, their behavior is affected in some way. On the right side, we see number of species. So more species recorded at the sites that had artificial light at night than at the dark sites. So what, you may say? So what about, how does that matter? Artificial light at night may decrease the overall efficiency of migration by increasing the time and energy requirements for migration, and these effects are potentially exacerbated by the scarcity of large patches of suitable stopover habitat within urban areas. So birds are attracted to areas of clusters of dwellings or even urban areas, but then there's not much food available to eat in those areas. So not only are the houses and other buildings disorienting due to their night lights, but when birds end a nightly flight, they rest and forage during the day once the light comes up. So they're in a strange place. They see habitat and fly to it. And if that habitat happens to be reflected, not real, as reflected from a window, the speed of the bird's flights as they're moving toward that habitat often means that the resulting inevitable collision is usually fatal, either immediately or after some time due to concussion or brain bleed. And it's estimated just in a very recent study that up to 1 billion birds die in building collisions every year in the US. So this is just a huge source of mortality for birds. The more we study, the more the numbers go up. So I want to turn now to thinking about ways for bolstering resilience of ecosystems and of bird populations. There are some obvious things that I've pointed out problems, and so then there's happily some obvious ways that people can mitigate those problems. Just about everybody can mitigate some factors that cause population declines of these birds. So we can pay attention to lights at night, to glass reflectivity. I did not talk about coffee yet, but just going through a list of things that we'll look at in later slides here in a second. So coffee in terms of what tree species they choose to plant, if they have a yard or not, and in terms of how they spend any volunteer time they may have. For people who own substantial land, actions that manage for complexity and also that restore fire to the landscape. Complexity and connectedness and fire are all three really important elements of high habitat quality for birds, and forest birds. Okay, going through these one at a time. We're often kind of unaware once we're inside our house, it's like a cocoon of the lights that are on outside. Turning off unnecessary lights, especially during the 6-week periods of major migration in the spring and in the fall, is a easy and important thing that you can do. Making glass visible to birds is now easier than ever. For buildings that are already constructed, there are lots of products. I just listed a few here, a few makers of products that have been evidence tested that help birds to detect the reflective glass. Birds, just like people, aren't born being able to detect glass, but people have a chance to learn. We don't move through through our space as fast as birds do, and we may clunk our head, but we soon learn to recognize the framing, etc., as likely holding glass. Birds often just have that one chance to make a mistake. So that's what individuals can do in existing homes. But a really exciting thing to me is the number of cities that have adopted bird-safe building, new construction policies. More than 30 city and states across the US have adopted these policies, and more than that in Canada as well. And just as an example of what such a policy requires, often it's the construction of buildings of 10,000 square feet or more, and all sky bridges in cities must have bird-safe glazing treatment. And that can encompass a wide variety of treatments, from it's called fritted glass to having window screens on to a number of creative and very attractive solutions. Some of these policies also include provisions for dimming and snuffing out the lights at night. If you're interested, you can take a look at the database on bird-safe building policies that Yale University has assembled. Cats are a huge predator of birds, and being a responsible cat owner not only is good for birds, it's good for the cats. It helps them to have longer lives and healthier lives. During the nesting season, dogs should be restrained when you're in natural areas to protect ground nesting birds. This is Wisconsin state law. anybody who has influence over their plantings in their yard should consider planting native species, and especially if you're planting trees, plant native oak trees. It's really easy to get native or relatively locally sourced trees, for example, from the Wisconsin DNR, which is currently accepting orders for plants, 2-year-old trees to be planted next year. Can encourage prescribed fire. There are several classes I've seen that have sprung up over the last 7 to 10 years in teaching people how to safely conduct prescribed fires. The DNR has recently developed a website that keeps track. This is a clip from the website that keeps track of prescribed fires and explains the importance of burning and for maintaining fire-dependent communities. And then I've got a couple of odds and ends here, but important to note, I think. Burdock is a killer of many small birds, not many small bird species, I should say. You see examples here of birds that have become entrapped in burdock flowers after they've matured. Burdock is a non-native species, and its elimination can remove this threat for bird species. I'm telling you things I know that you already know, but drinking shade-grown coffee, which preserves the overstory, as you see in this right-hand picture, does a lot more for birds foraging opportunities in the south than drinking sun-grown coffee. For those who have the opportunity, landowners that have suitable open sites, prairies like this, or lake or river adjacent properties, some species like purple martins and more difficult to deal with chimney swifts are dependent on human structures, like purple martin condominiums, as they're sometimes called. Purple martins, you can see from this population graph, have sharply declined in population size over the last 50 years. So everybody can do mitigation of some factors that cause population declines. People who have large land holdings can manage for complexity and connectedness and increase fire. So when I talk about complexity and connectedness, I'm thinking both about tree diversity, not complacently allowing natural forest succession to result in a forest that's all basswood and maple and walnut species. Not that any of those are at all bad, but diversity is better. And then thinking of, I didn't have time to talk about this, but protecting topographically diverse areas in large blocks, such as I understand that the Mississippi Valley Conservancy is doing a considerable amount of in the Driftless area, is important. And topographically diverse areas are important because with their different slopes and aspects and positions, in the valley versus up on top, they allow species to respond to the current climate conditions. If it's a heat wave or a cold snap, it can move within these topographically diverse areas to find the conditions that are best to help them thermoregulate. So in concluding, I'm going to return to this chart of bird population change over 50 years. Population declines are severe for some groups, including those dependent on forests, but they can be reversed as evidenced by the exceptional recovery of a few groups here, the waterfowl populations in particular, under what's called adaptive harvest management, so coordination by state and federal agency personnel, and then the associated allocation of millions of dollars devoted to wetland protection and restoration. This can provide a model for proactive conservation in other habitats that are widespread. I've focused here on kind of development and urbanization, but agriculture, I just want to acknowledge, is equally responsible for habitat loss, and agricultural intensification is strongly linked to decline in insect diversity and biomass. There's clear evidence that population declines can be reversed. There's some examples of birds that have come off the endangered species list. So we already mentioned peregrine falcon in 1999 and the bald eagle, but also the brown pelican was down to just 12 breeding birds in Texas in 1973 when it was put on the endangered species list, and now there are in Texas alone more than 12,000 breeding. More recently, Kirtland's warblers have been delisted, although they'll also always be conservation reliant. Another good news species is the wood stork, shown in the lower right here, which is proposed for delisting and probably will be in the next year or two. So I want to thank you for your attention and thinking about some things that both individuals and larger landowners can do to mitigate negative factors that contribute to population decline of our forest birds. And thank you very much.
Thank you so much. Does anyone have any questions? Some of you joined late, but I will have this recording that I can share with everyone. Would anyone like to ask a question? No? Well, thank you so much for sharing all of the research. That was very interesting, especially because it was in the Kickapoo Valley area that, we know so well here. So we sure appreciate everything that you've shared. I do want to also tell everyone who's joined us, we do have several bird events that are coming up next year. We'll be having one that's all about grazing for birds, and that's a way that you can work as a farmer to actually increase your bird populations on your property. I'll also be having a bird hike at Sugar Creek Bluff again in May. So when we get to January, I'll have the whole list of events that are coming up on the website for everyone. And if you're interested in just doing birding, Sugar Creek Bluff is the absolute most amazing place. I think we counted over 80 species in an hour, and that was in May. So if you're interested, you can check out Plum Creek Conservation Area. There's 1,600 acres there of just amazing property. And now we've planted just acres and acres of trees there too. So we're hoping in the next generation, as those come up, it will definitely help with the forest there. So I think that's all we have then, unless there are any last questions. Anyone?
You have such an amazing area. I'm so impressed with all of the properties that you're managing. It's really great. Very
It's it's
uplifting.
it's amazing. The group that got us started in 1997 had such passion and heart, and because of that, it's just grown and grown. And we have so many great supporters who support the work we do, and we're just so thankful for everyone and all they've done to help.
It's great. Right. Well, thank you very much.
All right. Thank you so much. Have a great evening, everyone.
All right. Good night.
Thank you.